So hello everyone. So I welcome you to NEET World. So today we will be discussing the continuation to the last discussion of equilibrium. Here particularly Chatellier's principle. Okay. So which is very important topic of this equilibrium chapter. Okay. So here what exactly equilibrium or Chatelier principle says here. See, we know equilibrium system is a very stable system. For example, if there is an equilibrium between A and B, here we have a system A, B are in equilibrium. We know equilibrium state is a very stable state. So what happens by changing or by making any disturbance to the equilibrium? What happens to this system? So for example, I can disturb this equilibrium by increasing the concentration of this reactant A, or by increasing the concentration of product B here, or by decreasing the concentration of reactant or product. So what is the scenario here? This is what we can able to understand by looking at the Chatelier principle. So just read the definition here. It states that if a stress is applied to a system in equilibrium, then the equilibrium for time being gets disturbed. Yes, right? So that equilibrium gets disturbed if we apply any stress. Here stress indicates the change in concentration of reactants or products, or it can be a pressure in the case of gaseous reactants and products, or it can be a volume, or by addition of any inert gas, like that. Okay, or by change in temperature. This might be the thing here. Stress indicates it may be concentration, temperature, pressure, or volume. Okay, so as a result the system will move in a direction, the system or the equilibrium will move in a direction which tends to relieve the external stress. For example, I am applying stress to the reactant side, then equilibrium moves towards a product side, because to cancel, to nullify that whatever the external stress we have applied. Okay, for example, I am increasing the concentration of this reactant A. Now what happens? Concentration of reactant A is more now, the equilibrium gets disturbed. Therefore, the equilibrium moves forward. Why it is moving forward? Since the concentration of reactant A is increased, the equilibrium gets disturbed. So in order to nullify that, in order to nullify the whatever the increment we did, equilibrium favors forward. Okay. Again, after balancing the both sides, reactant side and product side concentrations, again we will get a new equilibrium. The equilibrium will get re-established. Okay, this is what happens here. Okay. So for example, in order to understand this, let us take one example. For formation of ammonia, I am taking N2 plus 3H2 gives rise to 2NH3 I am taking. Okay. So here, if we increase the concentration of N2 gas or H2, what happens to the equilibrium? Tell me. Forward. It favors forward. So now first condition we will be studying effect of concentration. Tell me what happens if concentration of reactants are increased, equilibrium moves forward in order to nullify that whatever the disturbance we made here. Okay. So if concentration, I am indicating with square bracket, of reactants here H2 and N2 are increased, equilibrium shifts forward. Okay. Now if concentration of product is increased, now what happens if product side concentration is increased? What happens? Equilibrium moves backward. Equilibrium shifts backward. Okay. So now see what I am doing, instead of increasing the concentration, I am decreasing the concentration of reactant. What happens? Tell me. If concentration of reactant is decreased, so tell me, if concentration of reactants are decreased, See, concentration of reactants are decreased means, here concentration is decreased means, in order to nullify that, equilibrium favors backward. So I can say same, if concentration of reactants is decreased, if concentration of reactant is decreased, equilibrium shifts backward. If concentration of product is decreased, forward. Now during the Haber's process, so Haber's process means that is a process used for production of ammonia, right now. So for production of ammonia, so what is the method we can do? Either increasing the concentration of reactants will favor production of ammonia, or decreasing the concentration of ammonia, the product formed here, will favor the reaction forward. It means whatever the ammonia formed during the reaction should be removed continuously. Therefore equilibrium favors forward, therefore more amount of ammonia is produced. For example, during this reaction, let us say delta H is equals to minus X kilojoules, I am saying, kilojoules per mole I am saying. So minus X kilojoules means what it is saying? During the production of ammonia, so heat is evolved. So I am saying some minus X kilojoules is released. So what does it mean? So this process is exothermic, you can understand. Okay, it means exothermic means reaction is favoring forward by releasing of heat. So system's heat decreasing or increasing? Decreasing. So final temperature of the system will be decreased when I compare with the initial temperature, right now. So forward reaction is favored by lowering the temperature. Okay, so low temperature favors forward reaction, high temperature favors high temperature favors backward. Why we are saying? If forward reaction is exothermic, then backward reaction will be endothermic. For a reversible reaction, if I am saying forward reaction is exothermic, backward will be endothermic. So I am saying exothermic reactions are favored by low temperature, then endothermic reactions will be favored by high temperature. Why? Endothermic reactions are favored by absorption of heat. Absorption of heat means temperature will be increased, right now. So effect of temperature also you got now. So tell me effect of temperature, second factor here. So tell me, for there are two types of reactions now. For exothermic, first you tell me, exothermic, thermic, so low temperatures favors forward, okay, whereas high temperatures, for exothermic if I increase the temperature, what happens? Backward goes, reaction or equilibrium goes backward, okay. And for endothermic, so delta H here negative, here it is positive, okay. So tell me here, endothermic, absorption of heat favors the forward direction. It means high temperatures favors forward, okay, and low temperature favors backward. So now tell me, for this process I have mentioned delta H is negative here. So whether exothermic or endothermic? Exothermic. So forward direction is favored by, ammonia production is favored by lowering the here as per these conditions, okay. So now next thing is I am saying, see, we will discuss about effect of pressure. Effect of pressure. So again I am writing same reaction here, N2 plus 3H2 Q raised to 2NH3 here, okay. So now look at here, all the things which are involved in the reaction are gaseous species only. So now whenever we have gaseous species, so what to consider here? See, we know ideal gas, you know now, there will be effect of pressure on gases only, there is no effect on solids. So effect of pressure will be seen in case of gaseous only. Okay, so now here initially, for example, I have here 4 I have, here I have 2. Okay, so consider total how many gaseous reactants are here. We have 3 plus 1, 4 I have, this side only 2 are there. So now complete reaction, complete equilibrium will be established in a closed container, right now in a closed container. First of all, I will tell you one single statement, then after that I will make you to understand. So increase in pressure, what happens to the equilibrium, they will ask. So increase in pressure favors which direction? How will you know this? So increase in pressure favors forward. Increase in pressure favors forward direction, I am saying. So why it is? Because see here, if I increase the pressure, increase the pressure means volume, what happens to the volume? Decreases. So if I increase the pressure, number of gas molecule present in unit volume increases. So for example, initially in unit volume we have 4. What I am saying, initially in unit volume we have 4. Reactant molecules are 4. Okay, so now by increasing pressure, what happens to the number of molecules in unit volume? Increases. Let us say it is doubling. Okay, so 4 becomes 8. Now product molecules are how many are there in unit volume? Initially 2 are there. So by increasing pressure it is becoming doubling, means it becomes 4. Okay, so what is the increment here? 4 become 8 means increased is 4. 2 becoming 4 means only 2. So where do we have more number of increments? Yeah, so number of molecules increased on the reactant side is more now. Therefore equilibrium will favors forward to decrease this, to nullify this increment, this greater increment. Okay, that's why increase in pressure will favors which direction? Forward. So how do you know this thing? See, wherever you have more number of gaseous moles, that side effect will be more. Okay, therefore equilibrium shifts in the opposite direction to that. Okay, if number of moles here are 4, see number of moles here is 4, here is 2. So which side is less? Lesser number of moles? Product side. Right now, so equilibrium will move that side wherever you have lesser number of moles in case of pressure. Okay, so just make a relation, delta Ng you make. So delta Ng calculate, it means number of gaseous products are how many are there? 2. Number of gaseous products minus number of gaseous reactants you take, gaseous reactants. So 2 minus 4, this is minus 2, delta Ng is negative. So now what you need to make? So delta Ng, you will get 2 types of relations now. Delta Ng is negative, less than 0, delta Ng greater than 0. Okay, so if delta Ng is less than 0, what happens, you tell me? So in this case delta Ng is less than 0 or greater than 0? Less than 0. So whenever you have delta Ng less than 0, so increase in pressure favors forward. Okay, if delta Ng is greater than 0, increase in pressure favors backward. Okay, that's it. Okay, is this clear or not? Yeah. So now tell me, for decomposition of PCl5, tell me PCl5 undergoes decomposition to give PCl3 plus Cl2. So what happens?
Delta Ng is 1.
So if increase in pressure, what happens to increase in pressure? If I increase the pressure, what happens to the equilibrium?
Backward direction.
Backward or forward?
Backward.
Backward. Why backward? I told you, wherever you have lesser number of moles, that side equilibrium will moves. Okay, so where do we have lesser number of moles?
PCl.
Reactant side. So increase in pressure favors backward direction. That's it. Very simple. Is this clear or not? Yeah. Next. Okay, so decrease in pressure, if I ask in this case only, same case I am saying, decrease in pressure. Decrease in pressure favors forward because decrement will be more here. Okay, decrease in pressure favors forward. It means for dissociation of PCl5, which is the best condition? Low pressure. So low pressure favors low pressure favors forward, whereas high pressure favors backward. So in this case, tell me, what is the favorable condition for production of ammonia? Low pressures or high pressures? High pressures. Why high pressures? So lesser number of moles is product side, so that will be favored by increase in pressure. So if you are getting confused, just remember these two things. Okay, if delta Ng is less than 0, increase in pressure favors forward. So lesser than 0 in this case, so increase in pressure favors forward. Then decrease in pressure favors backward. Okay, so just remember this thing, you will get everything clear.
So for association, increase in pressure is forward,
Yeah.
decomposition, increase in pressure
Back. Like always remember, lesser number of moles side, that will be shifting by increase in pressure. Okay, next we have effect of volume.
effect of inert gas.
Like that is what effect of inert gas. It means by addition of inert gas, what happens? Inert gas. By addition of inert gas, volume of the container increases. See, for example, initially a closed container having equilibrium reaction is at here. So by addition of inert gas, does inert gas involve in the chemical reaction? No, only that will dilute the reaction. Right now that will increases the volume. So now finally volume becomes somewhere here. It means volume got increased. So volume increased means number of moles of species present in unit volume
Increase.
once again, number of gas like reacting species present in unit volume decreases. See, initially for example here we have 4. Now after diluting it, what happens to the volume? Volume is increasing. So volume becomes half, I can say. If the volume the number of moles present in unit volume becomes half, I can say, if volume is doubled. Okay, for example, same ammonia reaction I am taking. N2 plus 3H2 gives rise to 2NH3. So here we have 4 gaseous reactants, here we have 2 gaseous products. Okay, so now what happens is I am adding some inert gas, let us say helium gas we are adding. Okay, helium gas we are adding. So now what happens to the equilibrium, tell me? See, when we add helium gas to the equilibrium, like total volume is getting doubled, we can say. Let us say volume is getting doubled. Okay, if volume is getting doubled, number of moles present in unit volume, number of these reactants and products present in unit volume decreases. Initially we are having 4 and 2, 4 reactants, 2 products. Okay, but this becomes number of moles present in unit volume decreases. So decreased by half, let us say. So this becomes 2 and this becomes 1. So where do we have greater number of decrement? Here decrement is 2, here decrement is 1. So where do we have more number of gaseous molecules decreased? Here, this side now. So it means effect will be, the equilibrium will be shifts backward, because the decrement number is more here. Okay, so just take, if delta Ng is greater than 0 and delta Ng less than 0, so these are the two things you should remember. So if delta Ng is less than 0, by addition of inert gas favors backward. So here, as in this case,
Yes.
okay, if delta Ng is greater than 0, forward. Okay, so just remember something like opposite to the effect of pressure.
Constant volume.
I will tell you. So at effect of pressure, what we have studied? If delta Ng is delta Ng is less than 0, forward reaction. Here it is backward. That's it. Okay. So effect of inert gas. It means addition of inert gas at a constant pressure. What is constant here in this case?
Pressure.
Constant pressure. Whatever we have studied till now, this is under constant pressure. Okay. So once again you tell me for this PCl5 dissociation, Tell me equilibrium favors which side?
Forward.
Consider all of them are in gaseous state.
Forward.
So addition of helium gas favors reaction which side?
Forward.
See, number of moles are greater this side, then decrement will be more in that side only, therefore equilibrium moves forward to nullify the decrement.
And
Okay, so addition of inert gas favors forward direction. Okay, and if you want you can make delta in G is greater than 0. So this also indicates what we have studied, greater than 0 means forward direction. Okay, it's better to remember concept, not this delta in G, delta. This is also useful in the exam, but if you got confused with this, just use the concept like decrement, increment you check, you will get the clarity. Okay, right, next. So now what? Addition of inert gas at constant volume. If I add inert gas at constant volume, what happens? See, inert gas has no involvement in the chemical reaction right now, it just dilute the reaction by increasing the volume right now. So but constant volume, there is no change in volume, it means no effect. No change in volume means no effect on equilibrium. So addition of inert gas at constant volume has no effect. Only addition of inert gas have effect at constant pressure. Okay, yes. So now for example H2 plus I2 gives rise to 2H, I am saying. So here if you observe delta in G is 2 minus 2 0. So do we have any effect in this case? No effect. Here also there is no effect. Okay, because number of gases, reactants and products are same here. Okay, therefore no effect here. Okay, so these are the things we have seen. So tell me, first one, is this clear or not? Effect of change in concentration. Next, effect of pressure.
Yes.
That is also clear. Okay, so next, effect of temperature.
Yes.
Yeah, so effect of temperature, we can have one equation. Okay, yeah, exothermic, endothermic we have discussed. So log K2 by K1. So K2 is the equilibrium constant at temperature T2. Okay, so that is given like this, log K2 by K1 equals to delta H by 2.303 or 1 by T1 minus 1 by T2. So here at T1 temperature we have equilibrium constant as K1, at T2 K2. It means if you change the temperature, the value of equilibrium constant also changes. That's why we got K1 and K2 at temperatures T1 and T2 respectively here. Okay, so now for endothermic reaction, what I am saying for endothermic. So for endothermic, tell me, I am saying T2 is greater than T1.
Yes.
So it means final temperature is greater than initial temperature. So now greater temperature means, whether tell me final temperature is greater means equilibrium favors forward or backward. For endothermic,
Final temperature is
greater.
backward.
Endothermic, forward reactions are favored by increase in temperature. So final temperature is greater. So forward reaction is favored. So forward reaction is favored means its equilibrium constant value increases. So if T2 is greater than T1, therefore I can say K2 will be greater than K1. Are you getting what I am saying here? So similarly, if I say same for endothermic reaction, if T1 is greater than T2, now tell me, if T1 is greater, so K1 will be greater than K2. So for exothermic, you tell me, opposite means what exactly? For exothermic, if T2 is greater than T1, then exothermic reaction, forward reaction is favored by lower temperature, but here temperature is raised. It means, is it favored? No, right now it means its K2 will be lesser than K1. So I can write K2 will be lesser than K1 if T2 is greater. Okay, and the other condition, if T1 is greater than T2.
K2 is greater
Ah,
than K1.
K2 is greater than
K1.
K1. Is this clear or not? Yeah, this is very important again. Okay, so yeah, so tell me, is this clear? Effect of concentration, temperature is clear, and effect of pressure is also clear. Next, addition of catalyst. Addition of catalyst, see, catalyst will make the reaction to happen sooner. It means it helps to attain equilibrium very faster, but there is no net effect on equilibrium reaction. Okay, so it makes the reaction to happen faster, that's it. Okay, and addition of inert gas, we have two conditions. One is
Constant temperature.
at constant volume and at constant volume and at constant pressure. One is V constant, other one is P constant. So at volume constant, no effect. At pressure constant, we have some effect. Okay, so at constant pressure, what I told you, addition of inert gas favors wherever we have more number of gaseous moles. What I am saying, addition of inert gas favors wherever we have more number of gaseous moles.
Or more decrement.
Okay, yeah, so you can remember one statement, addition of inert gas at constant pressure favors wherever we have more number of gaseous moles. Okay, at constant pressure, like this is over, constant pressure is over. Now constant volume, no effect. And again tell me effect of pressure.
Effect of pressure where number of moles are less.
So increase in pressure favors wherever we have lesser number of
Moles.
gaseous moles. Okay, that's it. Okay, now yeah, so now I will tell you few questions, just answer them. I'll show you few questions here. Try to answer this question. Read this. Read this and answer it.
Is it at constant temperature, constant volume or pressure?
That is what not clearly mentioned, right now. So if you assume it is at constant pressure, what is your answer? If it is at constant pressure means addition of helium gas, inert gas now. So addition of inert gas favors reaction wherever we have greater number of gaseous moles. Greater number of gaseous moles are this side, so equilibrium favors forward. Okay, they are saying forward direction. So this will be the answer at constant pressure. If it is at constant volume, has no effect. Addition of helium gas has no effect on equilibrium. So as of now we can go with A and D both. But if it is constant pressure, first option. If it is constant volume, last option. Right. Next. We have one more question, I think so, somewhere. Tell me here. Answer this.
Option B.
See, first of all, what it is releasing? Heat. So if during the reaction heat is released means exothermic. Exothermic reactions are favored by low temperature. So low temperature here we have. Next, what about pressure?
High pressure, least number of gaseous molecules.
So effect of pressure means increase in pressure favors
Forward when in which the gaseous species are
less. So number of moles are less here, so it favors forward. So high pressure favors forward. Here we have option B as the best answer. Okay. So next question I will tell you here, you just write it. like formation of NO2, or I mean not formation of NO2, decomposition of N2O4 to form NO2. NO2.
Effect of pressure.
Tell me, what are the possible ways we can answer this? I mean, effect of concentration, you tell me. If we increase the concentration of reactant, products like NO2 is formed here, or by decreasing the concentration of
NO2
forward reaction is favored. I am asking for production of NO2, I am asking. So, production of NO2 means either we should increase the concentration of reactant or decrease the concentration of product, that is it. And next, effect of pressure, you tell me. Effect of pressure.
Increasing the pressure.
Effect of pressure, and one more thing, effect of inert gas also you make it.
Effect of inert gas. Addition of inert gas by pressure. Addition, yes.
See, what I am asking now, effect of pressure. Effect of pressure, see, more number of moles which side? This side more number of moles are there. So, if I increase the pressure, what happens? Backward it is favored, but I want forward. So, low pressure favors
Addition of inert gas.
so addition of inert gas, tell me.
We should add addition forward reaction. Suppose.
So, I want for production of NO2.
Yes.
So, for addition of inert gas, if I add the inert gas to this, what happens? Equilibrium favors wherever we have more greater number of gaseous moles. So, greater number of gaseous moles are here. So, equilibrium favors forward. Addition of inert gas favors forward, means for NO2 formation. And next, addition of effect of temperature. So, they haven't given exothermic or endothermic. Generally, it is endothermic first of all, but if we do not know, just use this equation, delta H minus T delta S we have right now. So, I am keeping delta H aside. Okay. So, now what about delta S? Entropy change. Look at the reaction. Entropy, here we have 2 and here we have 1. So, delta Ng is what? 2 minus 1 means 1. It means delta Ng is greater than 0. It means entropy increasing. Entropy is increasing now. So, entropy is positive here. So, it means the second term becomes negative. See, from where I have got this equation, delta G equals to delta H minus T delta S. Okay. So, we know for a spontaneous process, delta G has to be negative, right now. So, in order to make it negative, so here definitely this term has to dominate, whether because we do not know, you are saying now. So, if we are not knowing about delta H, this second term must be dominating factor. Okay. It means in order to make it domination, so what should be the major factor? We know this is definitely positive, we have a negative sign here. So, make it bigger negative. Making bigger negative is possible with higher value of temperature. So, I can say high temperature. Is that clear or not?
Yes.
Yeah. So, write this example. So, do you have books? If you have, you can solve questions also on Chatelier principle. Very important it is. right? H2 plus I2 gives rise to 2HI. H2 plus I2 gives rise to 2HI. So for formation of HI, favorable conditions are, tell me what are the favorable conditions? Again, it is a endothermic process.
High temperature.
Exothermic process it is, exothermic process. Huh?
Low temperature.
Low temperatures.
Formation of
HI, for formation of HI, what are the favorable conditions?
low temperature.
Low temperature.
No effect of pressure.
Here delta Ng is 0 now in this case, H2 plus I2 gives rise to HI means delta Ng is 0.
No
So,
effect of pressure and no
effect of volume.
inert gas.
Inert gas, both, no effect. Next we have concentration. By increasing concentration of reactants or decreasing concentration of product will favors forward, that's it. Okay. And next we have, clear now, any doubts are there here? No. You just solve few more questions, based on that will be more clear. So now we have relationship between delta G and K equilibrium. See, it means, see, for a reaction, we have thermodynamic relation and temperature like delta G equals to delta G naught plus RT ln Q I am writing. Okay, Q means reaction quotient. Okay, so now, what I am saying, at equilibrium, so at equilibrium we know delta G will be 0. What is 0? Delta G is 0. So then standard Gibbs free energy delta G naught will be equals to minus RT ln, in the place of Q I am writing K. So what is Q here? We can say reaction quotient. What is that?
Reaction.
For example, I have a reaction A plus B gives rise to C plus D I am writing. See, this reaction is not at equilibrium. This is favoring towards forward, right now. So here if I write concentration of products by concentration of reactants, see this is not at equilibrium state now. So the concentration of product to the concentration of reactant should be called as reaction quotient at any other states other than equilibrium state. If the reaction is at equilibrium, it means A plus B, perfectly I am representing here A plus B are in equilibrium. Here this, see, if you see the arrow mark, one is greater, means favoring only one direction. Okay, so here you should not say Q, it should be K or Kc. So that will be concentration of C products by concentration of reactants. Okay, so this will be the case at equilibrium. So you can use K means here whatever the value you will get here. Okay, if I say K forward equals to 10 power 2 and K backward equals to 10 power 3 or like this I am giving you. So what is equilibrium constant? Kc, equilibrium constant. Do you remember? This is what? Kf by Kb. Remember, K forward by K backward. So that is 10 power 2 by 10 power 3. So 10 power minus 1 we can write. Okay. So this is what? The Kc value here. Okay. So now put this Kc value over here. Okay. Temperature they will give some value. You can substitute to get the answer. So I can write delta Z naught equals to minus 2.303 RT log K. Okay. So now, or I can also relate by giving delta G naught value. Sometimes they may ask equilibrium constant value also. So K will be equals to what? Delta G naught by RT minus RT. So ln, if I send this side, here it will be exponential. Okay, this one also you can use. Or in terms of logarithms, if I do from here, what will get? Tell me. K will be equals to 10 to the power minus delta G naught by 2.303 RT. We will get this 2. Okay, write this values, formulas.
For dispatch
So they will simply gives you, I mean, simply they will give you some like substituted values, I mean easily calculatable values to put here and get the answer at least. Okay. Now okay, I will show you one or two questions here based on this. That one simple one I will give you first. Look at this, try this once. Tell me your answer fast for this. So how simple only now, the standard Gibbs free energy change at 27 degrees Celsius they are asking. So it means what to do here, tell me.
First calculate Kc.
So delta G naught equals to minus 2.303 RT log.
They gave log value, so RT
Ln value they have given here.
2.3 log.
Okay, so log Kc. So tell me here, what is the value they have given? Kc value first find here from these two things.
10.
I already told you. Kc means what? K forward by K equilibrium constant equals to K forward by K backward. So that is 10 power 3 by 10 power 2. So it is 10. Okay. So you got log 10 here and minus 2.303, and what about R? See, they want it in kilojoules. Okay. So I can write 8.3 into 10 power minus 3 kilojoules I can take, multiplied with temperature. What is the temperature here? 727 now, so plus add 273. So totally it is 300 Kelvin. So multiply with 300. So log 10 is 1. So you got this as minus 2.303 into 8.3 into 10 power minus 3 into 300. So I can write this as 0.3 here. So 8.3 into 2.3, it is around 19.1 into 0.3. So this will be 357 minus, so 2 decimals here, so 5.73. So nearest integer 6. Okay, so that will be our answer for the question. Is this clear or not? Okay, so this is a JEE mains question, so you can try NEET questions also related to this. Okay, and one final question as a homework for you. So if you want, you can try this. And in the next class, we will start ionic equilibrium. This one only, no? Kp is given, that's it, same. So delta Z naught means what to do? Minus RT ln K. So K is given here, you can simplify that, you will get the answer. Okay, so that's it. If you have any doubts, you can ask me now. So those who are in online watching from home or live, so if you have any doubts, you can write in the chat box, and if you are new to this channel, click on the subscribe button.